Right, howdy and welcome. So this is the digital speakeasy, secure and anonymous access to your website. I'll get into what that means. So my name is Dustin Yachts. I am Mills Yacht basically everywhere. There's going to be some resources in this. Don't think you have to write everything down. The slides are actually already up at my GitHub under Prez, P-R-E-Z. You can check them out there. I am currently an engineer at Acquia. We're a small hosting company based out of Boston. Maybe you've heard of us. That joke went over way better in Montreal. Because I think some people there haven't actually heard of them. In a previous life, I used to work for Four Kitchens, which was an agency based out of Austin, Texas. There I ran support, which meant that I got to do a whole lot of really boring things. They're kind of the same over and over and over again. But every once in a while, I got to do something really cool. And one of those projects is where this talk came from. So if it isn't obvious, I'm not really a designer. I just wear shirts that make me look like one. But maybe you've heard of this guy, Mike Montero. He's a pretty cool guy. He runs a design shop out in San Francisco. And he also makes it a point to fight fascism at every turn. This talk put this together a year ago, and it was kind of a different climate than it is now. So I think this is even more important. So what is this digital speakeasy we're talking about? So we're going to do a quick bit of math since we're in MIT. Seems appropriate. It's not going to get too crazy. Don't worry. Public does not equal private. I think it's pretty straightforward, pretty basic. Public does not equal secret. That also makes sense. But here's one that may not make immediate sense. Secret doesn't equal private. Two different things. The internet is trusting by default. It's the way it was created. Just a bunch of academics who wanted to talk to each other. So it was designed to be, with the minimum amount of moving parts. They just wanted to get stuff from A to B. Any computer on a given network segment, you may or may not know this, has access to the data across that entire network segment from every other machine. With the right know-how, you can do some pretty fun things with that knowledge. So there's a couple different types of browsing. This comes back to the private versus secret. The most basic is plain text browsing. So this is how the internet was started, with the World Wide Web, HTTP. It's just a bunch of text files and images flying back and forth that anybody who knows how to can read. They're just sitting out there. Looks something like this. So this is just a very basic HTML web page. This is the content.
That's not what it looked like when the internet started.
No, it's come a long way. But that's not all that somebody can see. You also get stuff like this. So this is the rough metadata of that transaction. So it's not just what you were looking at, it's who was looking at it, when were they looking at it, sometimes where were they looking at it from. There's all kinds of metadata that goes along with every single request you make across the network. There was a fun toy that I used to play with. I got my first laptop with Wi-Fi in 2005. It was my last year of undergrad. I was kind of checked out. I was taking a bunch of last-minute, kind of lower-class credits to just finish up my degree. So I spent a lot of time sitting in the back of the classroom, pretty bored. Until I found this toy called Etherpeg. Etherpeg was a little program for OSX that would just sniff the network traffic going across the Wi-Fi, and anytime it saw an image, it would grab it and take that image and it would pop it onto my screen. So I would just sit there in class, just watching this go by. It's 2005, not a lot of people had laptops yet, which made it even better, because you could quickly identify who was doing what. There was one girl in one of my classes who, her two favorite pastimes were looking at pictures of herself as an amateur model and buying clothing for her dog. It was very obvious who it was in class, and it was pretty fantastic. Now you think, okay, that's 2005. Obviously, we've come a long way since then. Kind of, not really. So we've done some things. So we now have HTTPS, the secure version of the hypertext transfer protocol. This does things like gives a general encryption to the content. So the web page is no longer easily identifiable what it is. It's kind of jumbled up. But a lot of times you can still find this. The metadata is still sitting out there in plain text. If you're doing something like you're at work and you want to go to a specific website, they may not know what you looked at, but they now know that you go to that specific website. In a lot of cases, they not only know the website that you go to, but if you go to like Reddit, maybe you're going to Reddit/r/Drupal. That's good, that's fine. But there's a lot of other /r's that you might be going to, and they can start seeing stuff like that as well. So some cool stuff comes around. So now this is the first time we have the concept of browsing in private. So it's no longer a matter of keeping the content secret. It's a matter of keeping your browsing private. So the Onion router, Generation 0 and Generation 1, were created by the US Naval Research Lab back in the 90s. They were designed for literal spies, which I think is the coolest thing that I learned about Tor. I found the original paper, the first public release of this information from 1996. So what the Onion router does is it provides your browser a way to speak to other computers privately. So again, it's not about being secret, it's about being private. And what that means is other people don't know where you're going or where you're coming from. A little bit later, Tor was released. So the Onion router was created by the US Naval Research Lab. For some reason, I would love to know this story. They turned over the project to the EFF to run as an open source foundation project. And this was they considered Generation 2. This was designed for everyone. So this was the first time in 2002 you could download a Tor browser, connect to the Tor network as an end user, as a not spy, and you could use it to browse around, which is pretty cool. So Tor, what's Tor? This is the basic premise of Tor. When you are on the network, like I was saying, any given computer along the way can know who you are, what you want to know, you want to know it from. Tor uses a model where individual nodes only know about what's immediately behind them and immediately in front of them. They call this the rule of 3. And I like to think of it kind of like this. See no evil, hear no evil, do no evil. This first monkey is the first computer that you're talking to on the network. So the monkey knows who you are. Now that first monkey is going to randomly pick a second monkey to pass this along to. That second monkey only knows the first monkey. He doesn't know you. He only knows that there's some data that you want to get. The second monkey is going to find the third monkey. Now the third monkey only knows the second monkey. Doesn't know you, doesn't know the first monkey. And the third one is actually going to send the request on to the end server. So with only 3 hops, mathematically speaking, you have this privacy that you need because the chain is broken up along the way. And it seems kind of hard, doesn't it? Like, it just seems like a lot of work, a lot of math. I don't know about you, I don't like doing math a lot often. So why bother? Why should we care? I'm just looking at websites, right? Well, here's the thing. Not all governments are that forgiving. I think this is kind of number 1. They've heard of something called the Arab Spring. There's the Turkish coup. So these are instances where the population of a country realized that they could talk en masse to each other. They could organize around principles, and they decided we no longer want to be part of whatever the current government is doing. We want to rule ourselves. We want something to change. And in the case of the Arab Spring, a couple of countries are very successful. Some weren't so much. Just last year was the Turkish coup, where we went to bed in America, kind of hearing that maybe something was going to happen. And by the time we woke up, it was over. It was an 8-hour coup, and it was done. And it all came down to the power of the internet, the power of the communication between these people. And then stuff like this happened. So this was August 19th, 2016. This was I think it was about a week after the coup. Erdogan, the president of Turkey, he just arrested 40,000 people because when you're a dictator, those are the kinds of things you get to do. And this wasn't a random 40,000 people. These were 40,000 people that they found saying things he didn't want them to say on the internet, and he arrested them. So government's not always great. Jobs aren't always fully ethical. We have the examples of Edward Snowden, who is currently living somewhere in Russia. Chelsea Manning, who is now finally, thankfully, no longer in Fort Leavenworth. She has been released. But these were people who were just doing a job. They went to work for the government. They thought they were doing good things, and they saw some really awful stuff happening. And because they felt the need to tell people about that, they wound up, one of them can no longer come back to America, probably forever and ever. And the other was in prison for 7 years under some pretty onerous conditions. Just because they were doing what you were told to do. Like, they tried to tell somebody, they tried to blow the whistle, and it didn't work. And it's important to know that it's not just what you're saying, it's oftentimes what you're reading. The actual reading habits that you have can have consequences. So around this time last year, maybe you heard we had an election going on, and there's lots of stuff, so much stuff going on. Oh, it was very exhausting. One of the things that happened was there's the Open Societies Foundation. This is a group that is controlled by George Soros. He is a stupendously wealthy man who also happens to be incredibly liberal, which is kind of rare in this world. And he runs the foundation. One of the things the foundation runs is an online publishing wing called OpenSocietiesFoundation.org. That is a worldwide publication focused on civil rights, human rights, and just kind of the general liberal agenda around the world. August 14th, 2016, the entire foundation was hacked. And this was, nobody could wake up without hearing something new about Hillary Clinton's emails. This was kind of a similar thing where some hackers somewhere found a way in, stole a bunch of files, stole a bunch of email, and started leaking what they could find that they felt would be damaging to the Democratic election chances. And we have things like this. So this is an ad taken out by the EFF. And there's a lot of things that you can say about our now former president, Obama. He did a lot of great things, but he also did a lot of not so great things. And one of the things he did was he built a stupendously powerful surveillance engine. And somebody else just got the keys to that. So now we have something even more to worry about. It's one thing to have something capable of what the CIA or the NSA is capable of, but it's another thing to have that in the hands of somebody who doesn't have who doesn't just have the patience or the ability to think things through properly. So hey, Tor, yeah, let's get back to that. That sounds great. I now want to just do Tor everything. All I want is Tor. So Tor, you've got the 3 monkeys. This is all great. This is all well and good. But there's a problem. What if you don't trust all of the monkeys? What if one of those actually turns out to be a bad actor? And this is a known weakness of the Tor architecture. There's not a whole lot that can really be done about it. So like I said, we've got you or Alice up on the top left. You are trying to speak to Bob down here on the bottom right. In the middle, you've got the Tor network. You've got green links all the way. So this is simply saying that your traffic is private and secret. If you notice, that last talk to Bob is red. So that last computer, the third monkey, that's what they call the exit node. And to be an exit node is to be a computer link that connects from Tor back out onto the public network. This is literally a fire hose spewing back out onto the public internet. And it's really hard for a lot of good actors to be exit nodes if they wanted to be, because much like the internet itself, Tor has a lot of not so great stuff on it. You know, there's a lot of pornography. There's a lot of illegal transactions. You know, the Silk Road was built on Tor. So you know, places like universities, places that you might expect would want to do this type of thing, refuse to for legal reasons. So I was in grad school at the University of Texas, and we had, you know, amazingly fast internet. We're like, hey, we got this closet over here. Let's stick a computer in there. Exit node would be great. I think it lasted 6 days before they shut us down. And they shut us down pretty hard. They threatened that if we didn't shut that one computer down, they're going to turn our entire network off. Because they didn't want the university to have the liability of being that open node. There are other people who don't have that problem. People like the Chinese government. They love to run exit nodes because then they can just sit there and watch everything as it's coming off. They can, you know, inspect every single packet that's coming out of that exit node. Which, you know, for the average Tor user, it's not a big deal. But if you happen to be one of their Chinese citizens, that can be a really bad deal for you.
So that means they get to see what's being viewed, but not who's viewing it?
Depending on how the traffic is sent across the wire, yes. So that brings us to what the project that I got to work on was, which is the concept of hidden services. These are also called onion services. So a hidden service is when you actually have your server on the Tor network. So there's no longer that red link at the end. Your server is actually on the network. And it looks something like this. This is a Tor URL. It's not the prettiest thing. It's 16 cryptographic characters. This is the hash of a larger private key that identifies your server on the network, your node on the network. And then it ends in .onion, which at the time they just kind of picked because you can do things like that when you make your own networking layer. But it actually stands a chance to become a real TLD, which is pretty cool. So, you know, obviously that's not the most memorable thing. Some people do stuff like this. You might be surprised to learn Facebook has a public Tor node that you can connect to through the Tor network. It kind of confused me at first. You know, why would this corporation that wants to know everything about you allow you to have this secret side door? But then I realized, oh, well, once you're logged in, they know everything anyway, so what do they care? They just want you there. And if you're in a place like China that turns off access to various URLs, this is a way around that. This is, when you think about a domain name, think about a vanity domain name. Like, oh, if you have enough money, you can go out there and buy whatever you want. If you want ads.com, you could probably, for the right amount of money, buy that. No amount of money will buy this. Because, like I said, this is a cryptographic signature. So you have to do stuff like this. So this is an application called Scallion. It's an OpenCL application, which is a way of running operations directly against video cards, which are really good at this type of computation. And so the client that we were working with, they're like, okay, we want this hidden service, but we need something that's kind of memorable, so it's kind of brandable. So I sat down and I started playing with this application. And so you get 16 characters. And this lets you insert a certain number of arbitrary characters, starting from the left. And you know, I was like, okay, this is going to take a little while. Let me figure this out. I was like, what do you want? How many letters do you want to be specific? And they're like, oh, 9. I was like, okay, 9 letters out of 16. That's going to take a while. Let me just do a couple of test runs just to kind of get a feel for this. And so I think I did a 5-character one. And I let this run. This was on my MacBook Pro, my Mac Pro, my Tower, the big beefy processor and everything. And with 5 characters, it took 12 hours to generate one possibility. So I was like, okay, guys, I'm not sure 9 is realistic. Let's stop and think about this. Finally, we let it run for a while. We wound up with the 6-character arbitrary URL, which is pretty cool. But so this is just like the first part of this. So you see, yeah, so there's a hash. So that's like the actual URL. So that's a prefix, which is where you can insert the prefix, and then you get the private key. So this is like this is how you say who you are on the Tor network. This private key lives on your server, and people access it only if they know the actual URL, which is the hash of that private key. This is this is step one. So how do we actually do this? Like, it's just a URL. How do we hook this up to a website? They had a Drupal site, which is really nice. They wanted their Drupal site on the Tor network, which seems pretty straightforward. You just install a module, probably. So we went looking, and sure enough, there was a module. This module hadn't been touched in 3 years, which for a regular module, that's pretty bad. For anything security or privacy minded, that's like infinity. So we realized, okay, that's not going to work. They were thinking, okay, well, so Tor, it's a UNIX application. What if we just install it on the server? That could be useful. We just install it, we point it in the right place. But that's going to complicate the production server. It's one more thing that can break, one more thing that can go wrong. It can open up potential attack vectors. Your production server, you don't want it to be doing anything more than absolutely necessary. So say, okay, well, those are my entirety of ideas. What else? So we took a step back and thought about it. And that, there's the UNIX philosophy, small pieces loosely joined. This is a really good book. If you haven't read it, David Weinberger is a very smart man. And so I say, okay, let's do this the UNIX way. So instead of Tor being installed on the Drupal server, let's have a server in the middle, some type of relay along the way. This was possible primarily because the client was using Rackspace cloud hosting. This is really nice because it gives you a virtualized network where all of the computers live inside of the same virtual setup. They get internal IPs to talk to each other, which is really nice. But they're also just Linux servers, so you can install arbitrary stuff on them. This isn't the kind of thing that you could do on Pantheon. They don't like doing this kind of custom stuff. You couldn't do it easily on Acquia, but if you pay us enough money, we'll figure it out. Don't worry. So the idea was,
How about platform?
I'm not sure what their networking is like. Probably do it for the right amount of money. I think they're pretty flexible, which is nice. So the idea was, we wanted an end user on their computer to talk to the Tor network, and then the Tor network would retrieve the Drupal data. Us to creating an Nginx reverse proxy, which was super cool. This is the first time I've actually set up Nginx just from scratch. And I didn't realize just how flexible Nginx is, which is really nice. So it's similar to Apache in that it can be a web server, but it can also be so much else, which is just really cool. I found I really enjoyed the actual configuration of Nginx versus Apache, because with Apache, you spend a lot of time telling it what not to do. In Nginx, you're literally, you build it from scratch. Like every line tells it something new to do, and it doesn't do anything else, which is really nice. So it can be super simple, super fast, really easy to pin down problems. You're not digging through 19 comp files that are symlinked in some strange way. It's pretty nice. So what is nice about a reverse proxy setup? What's nice is the Drupal server is being accessed just as if there's a regular web connection. So as far as Drupal is concerned, this is just another person requesting a page. This means things like, if the server breaks, you don't get to blame Tor. It's something wrong with Drupal. And the Drupal server itself can continue to collect their logs normally. Because you want your watchdog logs. You want to know when something goes wrong. You want to know what went wrong. But a Tor server, because you want, if you're concerned about people's privacy, people's security, oftentimes you don't want things that can be subpoenaed. So you want to be able to do stuff like turn off the logs. So this worked really well. Configuring Tor, the application on a Linux server to run as a service, is so easy. This is literally it. And half those lines are commented out. You're telling it connect to the Tor network, you're telling it where it should read the data from. That's literally it. Nginx, takes a little bit more work. So basically what we're doing here is we are saying this is a web server, but it's going to read data from somewhere else. So we are at the very top, we've got the URL, the .onion address. It's going to listen on port 80 on a UNIX socket. This is just a security tip that was passed along. And you are going to point it to that same location that Tor is going to be looking for data. And then there's some other settings that are nice to have, but not necessary. But this gives us the ability to do this. So as I was saying, they were on Rackspace, which made a lot of this possible. If you're going to all this trouble, you don't necessarily want this data to be flowing over the public internet. So with this, we were able to set up internal private network using internal private IPs. So this means that the connection between Tor and Drupal is never exposed to the outside world. If somebody can still break into their network, but at that point you kind of got bigger problems to deal with. For our purposes, it was pretty ideal. So this is back to Nginx. So here we are saying that instead of looking in a given folder or a collection of HTML files, instead look at this IP address. This IP address is going to be the location of your data. And this is called this is the proxy pass setting. And there's some other proxy settings that we set. And basically, it's similar to if you're using Varnish as a reverse proxy or reverse cache. It's the same kind of concept where you're saying anytime somebody comes to you looking for something, don't tell them that it doesn't exist. Just reach into the back room and grab it and hand it to them. They never need to know about what's happening in the back room. They just need to know that when they ask for something to get it. Complicates things a little bit. Because, as you know, if you set up any amount of Drupal websites and give them to end users, they will find every way possible to embed an image. It doesn't matter how many file upload widgets you make, how many times you try to figure out something to where they just one-click an image. They will go out and find something and just dump the URL into the resume field. It's just what they're going to do. So we had to take into account, what if there's some type of link on this page, some resource, some link that somebody can click that takes them out of the Tor server. Whether it's they see a link on the sidebar and they click it, or there's an image that's fetching something from somewhere. So we wanted to turn off as much of that as possible. We wanted all of, anytime somebody was at that .onion address, they needed to stay at that .onion address. Their browser shouldn't talk to anybody else. And to do that, we use this cool Nginx HTTP substitution filter module. So one of the complications with Nginx is, while it has a lot of plugins and a lot of modules, a lot of them you wind up having to custom compile into Nginx. This is kind of a bummer. It's not insurmountable, but since they don't have a permanent sysadmin, I had to come up with some scripts to automate this a little bit, to make it a little bit easier on them so they can keep Nginx up to date. And here, we are simply finding a string, replacing that string. That's all we're doing. When you're dealing with publishers, they're always concerned about their SEO, even when you're setting up shady sub-internet connections. So I don't know that this is entirely necessary, but we are in fact going through and rewriting canonical URLs, so that even in the data that the user collects on their end, it's all going to be that .onion address. And then we go through, and anytime we see anything remotely close to the URL of the website, we're going to rewrite that to the onion address. And as far as Drupal is concerned, this is fine. It doesn't care, because it's just serving up its images normally. And then this is being rewritten on the fly, and then it shows up in the browser. It's really, it's kind of, it's beautiful in its simplicity. And then the last thing we do, this is just kind of being nice. We're just unsetting some headers. This is another module that we had to custom compile in. But this, it's just so that you're not lying to the internet, you're not lying to the browser. Again, not entirely necessary, but it's just kind of a nice to do. So that's all, guys. Tor sitting out there, we've got browsers talking to Tor. Tor goes to Drupal, collects the data, sends it back to the browser. But again, what if somebody shows up with a warrant? What if somebody wants to know what somebody was doing at 3 a.m. on Tuesday, January 22nd? So the ideal setup for this, all logging turned off. All log paths set to dev null, just in case, you never know. This is a little bit of belt and suspenders, but it made us feel a little bit better. This is the motto of my misspent youth. This is me, roughly 1998. And me now, prove anything. So one of the issues with telling people to do stuff like use Tor, or particularly use VPNs, while you're protecting the privacy from some things, you're also just kind of centralizing all of the data about what they were doing. So this is why it's important to think through what data is being collected along the way. Every time somebody comes to your Drupal site, a log is kept. The IP address is kept. One of the complications with this had to do with the Drupal flood table. So by default, the Drupal flood setup is set to look at IP addresses. The same IP address is logging in improperly over and over again, block it. But with Tor, a lot of people start sharing IP addresses. So that can be a little bit tricky. And it's something that can't really be solved at the Tor level, and it doesn't really need to be solved at the Drupal level. It's just something you got to know about. So the ideal setup for a 17-year-old anarchist. All the logging turned off. This was literally the most fun I've had on computers in a long time. If you're doing any kind of DevOps stuff or server admin stuff, there's all kinds of things that you're just not supposed to do. You're not supposed to just randomly install software. You're not supposed to turn off the logs. Boring, right? And one of the things, my first thought was, how do we have to turn off the logs? We'll just redirect them to dev null. Because dev null in Unix speak is a black hole. But then I learned that apparently, if you are a local root user, you can actually see stuff that's being written into that black hole. It's still a stream in Unix land. And that was kind of a TIL. That was really? And yeah, if you have enough access to a machine, you can see stuff that's being streamed before it actually gets to its destination, which is kind of crazy. So I got to do both. I got to do the belts and the suspenders. And this is another thing that's going to be very dependent on your host. This is something that, again, unless the stack cache is adequate, Aqua isn't going to do. Because they collect logs on everything. Because they not only want to know that your website's working, they need to know that your server's working properly, they need to know uptime percentages. Pantheon does the same kind of stuff. So it really helps that this particular client own the whole stack, roughly. It would be even more ideal if they own the hardware, but who owns hardware anymore? Basically nobody. What else can we do to make this better? We can increase the speed. So we've got the 3 monkeys. That's kind of extra steps that don't have to happen in a usual network connection. For the most part, nowadays, I used Tor for the first time probably 10, 12 years ago. It could introduce a lot of lag because it had to not only find the person that it was going to talk to, then it had to re-encrypt everything and send it along. Nowadays it's better, but it can still slow things down. So there's actually some projects underway to reduce the number of monkeys down to 1, which is actually kind of cool. They're calling it an onion single service. Single onion? Yeah, single onion service. As of December, this is now in the official Tor software. And so the idea is, if you are, if you're the Silk Road, you want to be private, and your end users want to be private. But if you are Facebook, or if you are ProPublica, and you want to provide this service to your end users, you don't really care about being private, because you are by nature a public entity. So you don't need to have your end covered. And so instead of going through 3 servers, you can literally move your server into the middle of the network. And then there's only what they call it a guard node. The first computer in the line is the only one that the end user needs to talk to. And you get data from that guard node, and you have no idea who asked for it. So you've got that secrecy from that direction, and you don't really care because you're already a known entity. So future improvements, single onion services. I'm really glad that happened. Onion balance, just thinking about how this would work really boggles my mind. But there is a project to introduce load balancing to a node on the Tor network, which sounds really cool. We do stuff like SSL certificates. A lot of people on the Tor network, they're like, well, why do you need an SSL certificate? Like, everything's already encrypted along the way. People already know that a given site is who they say they are by dint of the .onion TLD only being able to connect to a valid SSH key that matches it. There's no way around that. But sometimes it's still possible to be exposed to the malicious Tor nodes, the end nodes. Maybe you wanted that extra layer of protection of the SSL encryption. And again, your browser might try to communicate outside of the Onion network, and you want that traffic to be a little bit extra encrypted. So these guys, again, never thought I would say so many good things about Facebook in a single talk. But they went out and they convinced an SSL cert vendor to give them an SSL cert for a .onion address. Again, this is one of those things that, buy it. But at the time, they had to put in a lot of work. They had to work directly with DigiCert, who are, as of, I checked maybe a month ago, and probably for the foreseeable future, are the only game in town. They went through the trouble of getting .onion officially recognized as a special use TLD, a top-level domain. This is currently a temporary thing. Hopefully it becomes permanent because it means that you can walk to DigiCert and you can ask them very nicely. I think it's one of the expensive certs. It's like, I think it was a $500 cert. But you're able to say, this is my Onion address, and I please have an SSL cert. They give you one, and it's surprisingly a smooth process. It does involve an email. You can't just do it like one click, but we're able to do that for our client, and it's really cool. And in addition to giving you that little bit of extra SSL, it also gives you that nice green bar that everybody likes to see nowadays. It's all branding, folks. So what else could you do? So the thing about Tor is it's not just websites, it's not just web pages. Tor is its own networking layer, which is really cool. And that means that you can do crazy stuff. Every couple of years, there's a conference down in New York called HOPE, Hackers on Planet Earth, run by the 2600 magazine folks. I was there last year, and I got to meet some of the people working on the Tor software. And they're the most nervous people you will ever meet. They are convinced, and probably rightly so, that everybody is out to get them. So they do stuff like they run their own personal email servers and own personal calendar services all on the Tor network. Things that they can only access through Tor for that extra bit of paranoia. You can use Onion Share to do file share peer-to-peer, which is really nice. So again, it's a networking layer. So you're kind of stepping out of, you're bypassing NAT restrictions, you're bypassing a lot of like cable company restrictions, because you're at this different level of networking that they don't recognize, which is really cool. And again, it's a little bit slow. It has to go through a lot more hops than usual, but it works, and it's really nice. Non-hidden but protected sharing, which is, this is bringing it full circle. This is kind of the true speakeasy. So not only do you have to know the URL, you can also configure your server to where it only recognizes the known URL and a known good secret key. So it's like you're walking up to the speakeasy door, knocking, and still having to give the password. So this is, when they were setting up their email services, this is the kind of configuration they would use. And so with this, you can have, you can have a server that is not accessible unless somebody knows the secret. So this is kind of an extra layer of protection. And this is just kind of a fun one. You can circumvent DNS entirely. So just for fun, when I was working on this with the client, I was doing some stuff locally and wanted to show it to him. I realized it's on the Tor network. I can just give him the Tor address. He can view what I'm working on directly on my laptop. So if you've ever had to do like POW or what's another one? The services that let you share what you're locally working on onto a network without having to put it onto the server, you can do the same thing with Tor, which is actually kind of cool. That's just kind of a nerdy one. So resources, there's a whole bunch of these. They're very tiny. Don't write them down. They will be on the slides. But it is stuff like just kind of general. Tor project background, what Tor is, how it works, the setup from ProPublica. So my client was, he was excited about this idea because ProPublica did this on their website. So ProPublica is a nonprofit publication that is concerned with human rights and privacy issues. And so a lot of the actual hard work was done by them. They're super great. They shared everything on GitHub, which is fantastic. Some background on the SSL certs, background on vanity URLs, and some of the new stuff that's coming down the line, like the single ending services. Thank you. Any questions? Yes.
So, first of all, HTTPS does not actually encrypt using Rock 13. I just want to point that. But more serious question. You were able to generate a public-private key pair that hashed, and you were able to choose 6 characters?
1 to 6, yes.
Leaving 10 free. 10 hex digits?
No, they're often.
They're not there. Okay. So that's still quite a lot. So I'm wondering how many nodes there are currently on the Tor network. And if I were trying to impersonate one, I don't care which one, how comparable is that to yours? Probably still a lot harder.
Yeah, it's still very hard. It's doable. There are proven attacks. I don't know if anybody has published how to do it. They are working on upping entropy in the Tor network. They're always improving the cryptography along the way. So yeah, there are issues. Again, it's something that's most of it is still based on that 20-year-old paper. So they are working on improving it. In the last couple of years, in particular, they've gotten some good funding. Yeah, one of the problems, particularly if you cut off those 6, you've now cut out 6 digits of the entropy. That makes it that much easier for somebody to reverse engineer the key. So it is possible, but it's not easy. I think what happens, I believe the first one on the network wins, which is kind of a problem. So if you maintain an active connection to the Tor network, even if somebody manages to reverse engineer it, they're not going to be able to get on. But if you hiccup on the network at any point, they would be able to force themselves in. Yep. Anything else? All right, you have the slides if you need. Make your lunch. Have a good day.